name is Zach Kowal, and I am the Architectural Project Manager for the Northwestern University Ryan Walter Athletic Center project. This project is a 450,000 square foot sports complex that will be used to accommodate over 500 student athletes for Northwestern University. This is a very critical project for the university, which will be used as a marketing tool for future athletes. This job will consist of mixed-use offices, hydrotherapy areas, and a turf field located on the second floor. On the first floor, it will also house a basketball court for future athletes. This is the second installation in the United States of a slab-on-metal deck turf field, first being at Boulder, Colorado University. This is a unique installation because there's a lot of mathematics required to predict the tolerances needed when the steel settles after the concrete is poured. That will play a major factor in the polarity of the field needed to install the turf and meet our FIFA certification requirements.
My name is Kyle Welch. I'm a project engineer on the Northwestern University Ryan Walter Athletic Center. As a project engineer, I handle the technical review and management of the structural steel scope. This project consists of 3,400 tons of steel framing and 500 tons of box tube arches. As you can see, we're building a large facility on a relatively small site. We're essentially building on a beach on the coast of Lake Michigan, so the structure itself sits on more than 100 belled caissons. Working in the elements with the exposure to Lake Michigan, you have to plan around weather and wind, especially for critical lifts like today. Today we will be setting our third roof module, which is the center point of the dome, consisting of the tallest arches on the project. They'll be spliced together in the air at about 130 feet above Lake Michigan. Our pick weight is about 95,000 pounds with all of our rigging, and the whole process will take about 6 hours. There's 12 arches in total. We build them on the ground in the north and south halves of 2 arches, complete with the purlins and tie rods in between. Then, using the 2 massive crawler cranes behind me, they're lifted and turned and set into the position. The modular assemblies allow for less work to be done up in the air. We have a more controlled environment that we can reach on several man lifts and ladders from the ground, allowing the individual sections of arches to be constructed much quicker. Also, it takes away the safety concern of working under people above. Each arch is made up of 6 box tube segments that are hollow 3-foot by 2-foot sections of steel. They're spliced together with a bolted connection on the ground, and so when we assemble them in the air, there's only the bolted splice at the top of the arch.
The biggest challenge for this project is meeting the schedule deadlines required for our alternate number 9, which is early turnover of the field house. In order to meet our structural dates, we had to make sure we poured our concrete ahead of schedule, which included over 3,800 cubic yards of foundation work needed to accommodate the 4,500 tons of steel that will sit on top. Safety in working on an occupied campus is very important to the university as well as Barton Malow. It's important that we schedule our day-to-day operations around ongoing events taking place on campus. We're always cognizant of the students who are walking around campus and making sure that we're working as safely as we possibly can.